Welcome to lesson 8.2. In this lesson, you're going to learn how to accurately graph a quadratic equation. So if you recall in lesson 8.1, we were sketching quadratic equations using the axis of symmetry and the vertex. So it was just a very brief sketch. So I'll scroll up here just to show you. Using the axis of symmetry and the vertex, you would just make a sketch of the graph, right? So you really only had this line, axis of symmetry, and this point, the vertex. We don't really know if this side of the quadratic and this side of the quadratic are actually correct, right? We need the actual points that would lie on the parabola in order to graph it accurately. And we also knew whether or not it would face upward or downward, which is a great start, of course. But in order to be more accurate, you will have to create a table. Okay? So here are the steps. First, again, you're going to find the axis of symmetry and then the vertex. You know how to do that. You're going to put the vertex in the middle row of the table. So you're going to create a table of XY values. And then you're going to fill in the table using your calculator. So you're actually going to substitute numbers for X so that you can find out what Y will be. And you're going to plot those points on the graph and connect them to make your U-shaped parabola. Let's read the definitions. The directions. We're going to graph each quadratic equation using a table. Then we're going to identify the axis of symmetry, the vertex, and then the domain and range. Okay? Let's begin. First, we have the parent function. Y equals x squared is the parent function of quadratics. We call this the parent function because any other quadratic equation comes from this basic equation here, right? So I could write y equals x squared, but then I could write plus 2x, right? I could write y equals x squared, but then I could put like maybe a 2 in the front. So now y equals 2x squared. That's a different parabola. You know, so on and so forth. I could write plus 3 at the back here, and now that's a different parabola. So all parabolas come from this basic first setup called the parent function. Okay? Let's begin. Finding the axis of symmetry for our parent function. Okay. I'm going to go ahead and walk you through the steps again of finding axis of symmetry and vertex. However, you should remember that for our parent function, the axis of symmetry is going to be x equals 0. Okay? But I'm going to go ahead and do the steps anyway to show you how that actually happens. If you notice, we don't have a b value. We only have our a value, which is 1. So if you think back to section 8.1 where we did an example where there was no b value, so then you write that b is 0 divided by 2a and our a is 1. So you know exactly what's going to happen. 0 divided by anything would just give you 0. So that's how the axis of symmetry is 0. And I'm just going to go ahead and already plot that on the graph. You can barely see that, so I just want to fix it up. Here we go. There goes the axis of symmetry. Okay? All right, now the vertex. Again, thinking back to section 8.1, the vertex would be 0, comma, and that second number would be your c value if b is 0, right? Well, we don't have a c value in our equation. If we look at our equation here, there's no c value. We only have a. So therefore, c is also 0. So these are things that you should have memorized. Yes, we worked it out now, but you should memorize that for a parent function of quadratics, y equals x squared, the axis symmetry is 0 and the vertex is 0, 0. Simple. Okay? Let's move on to our table. Once you have the axis symmetry and you have the vertex, step 3 is to put them in the middle of your table. So the vertex is 0, 0, and it's going to go right in the middle of my table. Now, using that information, I need to choose x values. So I'm coming up with these x values completely on my own. So I want numbers that come before 0, like -1 and -2, and numbers that come after 0, like 1 and 2. Those will work. Okay? Now, in order to get the y values, I do need to plug this number in to x. Once I plug -2 to x, I can then find out what y is. So let's do that now. Where do I have space? Let's make space over here to the side. Okay. So I'm going to plug in my first x value into the function. Remember that the function is y equals x squared. So now I'm replacing x with -2. My first number will be -2 here for x. Okay? So I'm doing y equals parentheses -2 to the second power, and that's 4. So now I can go to the table and put 4. Let's do our next number. Y equals, we're looking in the table here, our next number is -1. So y equals parentheses -1 to the second power. -1 to the second power is 1. Going to my next number in the table, +1. Y equals +1 to the second power, which is 1. Put that on the table. My last x value is 2. So y equals 2 to the second power, which is 4. And I can put that on the table as well. Okay, so now my table is complete. These are the points that are going to go on the graph. So we're doing -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Let's go ahead and plot that now. I'm going to start by plotting the vertex, which is in the middle of the table. The vertex is here. So I'm plotting 0, 0 on the graph. After I plot 0, 0, I'm going to move on to my first point, -2, 4. Here's -2. 1, 2, 3. This would be 4. So -2, 4 is located right here. Then I'm going to -1, 1. Here's -1. Here's +1. So this is -1, 1 right here. Next point is 1, 1. Here's 1, 1. There's my point, 1, 1. Next point is 2, 4, 2, up 4. Here's the next point. Okay, and now we're going to connect those 5 points using a parabola. And that's as straight as I could get that, as perfectly round as I could get that. So there's our completed parabola. Okay, just in case you wanted to fill these numbers in, this was -1 and -2. This was 1, 2, and then 1, 2, 3, 4. Our first parabola is accurately graphed. Done. And we're now moving on to the domain and range, okay? The domain for quadratic functions are all real numbers. All real numbers, which sometimes looks like this little symbol here, okay? The range are the y values that are covered by my graph. So notice in the table, right, my lowest y value, what's my lowest y value in the table? The lowest y value is 0. And I'm saying the lowest because the graph is pointing upwards. So it has a minimum. It has a minimum. And that lowest value is 0. This is the lowest value right here, 0. So the range is going to be y values that are greater than or equal to 0. Any y values that are greater than or equal to 0 are going to be a part of this parabola, this shape here. So we're going to have some y values at 1, 2, 3, 3.5, 4, 4.2. Any y value that's greater than 1, like imagine if this parabola was to just continue forever and ever, that's exactly what would happen. We would have all the y values that are greater than 0. Okay, greater than or equal to 0. All right, that's the first example done. Let's go ahead and move on to number 2, which is a little bit of a longer quadratic equation. So first I'm going to start by marking A, B, and C. That is going to help me identify the axis of symmetry, similar to the last lesson, okay? And this is actually going to be the last problem where I work out the axis of symmetry in the vertex, because you've already had a lesson on how to find axis of symmetry in vertex. So I won't be working those out after this equation, after this example. So for when I move to number 3, I'm just going to skip to filling in the table, graphing, and then finding the domain and range. All right, so let's go ahead with the axis of symmetry for number 2. The axis of symmetry is going to be x is equal to negative b over 2a. Our b is 2, so negative b would be negative 2. 2 times a is 1, so we're doing 2 times 1. We have negative 2 at the top, positive 2 at the bottom. Negative 2 divided by 2 is negative 1. So my axis of symmetry is x equals negative 1. I now plug that axis of symmetry back into my original equation. So I'm going to copy the equation again, y equals x squared plus 2x minus 1, and replace the x's with negative 1. So we're writing y equals negative 1 to the second power plus 2 times negative 1, I'm right here, minus 1. So now we have negative 1 to the second power plus 2 times negative 1. Now, of course, you could work this out yourself, but it's just much easier to utilize a calculator when you can, especially when you're taking the EOC, because it's much faster and you won't waste time working on things in your head when you could use that time to work on other problems. Okay, so as you saw, the EOC calculator gave me negative 2. So now I know that the vertex is negative 1, comma, negative 2. My next step is to put that in the middle of the table, negative 1, negative 2. After you do that, you're going to choose numbers that are less than negative 1 and some numbers that are greater than -1. So less than -1, we're going to do -2 and -3. Greater than -1, we're going to do 0 and 1. And I'm just counting by ones, as you can see. Okay. Now, how do you get the y values? You take these numbers, you take your x's, and you plug them in one by one into the equation, just like you did this one. Okay? So we're going to use the EOC calculator for that. I'm not going to put the work, well, you know, I'll put the work here for this problem. But once I move on, I'm not going to put the work for every single step, just so that we can save time and not make this video super long. Okay, so you copy your equation, y equals x squared plus 2x minus 1. And you're going to replace the x's with these x's. So first, I'm going to start with -3. So now I'm doing y equals -3 to the second power plus 2 times -3 minus 1. And I'm putting that directly into the EOC calculator. Now notice, I already plugged it into the calculator before with the -1. So I'm just going to backspace the -1 and put -3 instead. That's the good thing about the EOC calculator, is that you can replace things without having to delete all of your work. It just works faster. So as you can see, this is what I put in, which is what we wrote earlier, exactly what we wrote earlier. And the answer that I got is +2. So this is 2 here, and we're going to go to the table and put the 2 next to -3. Okay? Now go ahead and try to do -2, 0, and 1 on your own to find out what the y values are. And you're going to see me do the steps here on the calculator. Oh, I shouldn't have cleared it. I just said that I could just type it, but that's okay. And I got -1. Now I'm going to do 0. Replace that with 0. This is what I typed in. I got -1. And last, I'm just going to do 1. Here, we're just going to put 1. 1. So this is what I typed in. And I got the answer is 2. So I can go ahead and put that on the table. There we go. My table is complete. Now, before I start graphing, I want to point something out. By putting your vertex in the middle of the table and then choosing numbers that are below this axis of symmetry and numbers that are above the axis of symmetry, you're going to create a pattern here. Oh, sorry. You're going to create a pattern here. Notice how the numbers that are around the axis of symmetry, I'm going to box off the axis of symmetry real quick. I mean the vertex real quick. Notice how the numbers around are repeating. -1, -1. 2, 2. Let's look at the last example. Here's your vertex Look around the vertex. 1, 1. 4, 4. If you choose your x coordinates correctly, right, this symmetry, this repetition will always happen because a parabola is perfectly symmetrical on both sides of the axis of symmetry. The axis of symmetry is perfectly in the middle, and both sides are exactly the same, right? So you're going to be able to see that in the table as well. Here's your axis of symmetry, and both sides are exactly the same, as you can see, okay? So you'll get to a point where you can work out these first two in the EOC calculator, but once you get these two answers, you'll already know that these two answers would be perfectly symmetrical to those. So you'll be able to do a shortcut to getting the last two answers, if that makes sense. Okay, let's move on to graphing. Again, with the steps to graphing, the first thing you're going to do is graph your axis of symmetry. The axis of symmetry is x equals -1, which would be this line here. This is the -1 line. Okay? Then you're going to plot your vertex, which is -1, -2. So I'm going to plot -1, -2, which would be here, because this is -1, and this right here is -2. Okay. There goes my vertex. And now I'm going to plot my first point, -3, 2. -3, up 2. So that point is right here, -3, 2. Then I'm going to -2, -1, -2, -1 is here. 0, -1, 0, -1, here, and then 1, 2, 1, 2. Oh, I'm sorry, 1, 2. I put 1, 1, 1, 2. +1. -2, negative. That's why this point here is wrong. That's wrong. This one is wrong. The point is -2, -1, and I plotted -2, +1. Okay? So -2, -1 would be here. Therefore, this is our parabola here. Okay. Lastly, we're going to do the domain and range. Remember, domain for quadratics would be all real numbers, which also looks like this. And then our lowest y value in the table is -2. We know that that's the lowest point since it is the vertex. So the range are y values that are greater than or equal to -2. Okay? Now we've done two parabolas that are facing upwards. So the next example, we're going to do a parabola that faces downwards and see how that changes some of our answers. I'm just going to do the even problems only. So the last examples you're going to see are example 4, example 6, example 8, example 10. Okay? And that will be the end of this video. Let's start with number 4. With number 4, the equation is y equals -2x squared plus 4x plus 1. We're still learning how to graph quadratics accurately. So here's our a value. Here is the B value, and here is C. Okay. First, we're going to find the axis of symmetry, so we're doing x equals negative b over 2a. I did say that I was going to stop showing the axis of symmetry, how to do it, since you already had that in lesson 8.1. So you're going to work that out on your own, and you should get that the axis of symmetry is positive 1. So x equals 1. Then you plug that 1 back in here and here. So we're doing negative 2 parentheses, excuse me, one second power plus 4 parentheses 1 plus 1, and I get 3 as the answer. So the vertex is 1, 3. And you know you should directly go and put that in the middle of your table. Next, we're going to choose some numbers that are less than 1, 0, and negative 1, and then some numbers greater than 1, 2, and 3. Again, I'm going to go to my EOC calculator to figure out what the y values will be. You would first start by copying the equation y equals negative 2x squared plus 4x plus 1, and you're going to plug your first number, which is negative 1. So the x is going to be negative 1, this x is negative 1, so we have y equals negative 2 parentheses negative 1 to the second power plus 4 times negative 1 plus 1. Going directly into the EOC calculator, I can see, oh, didn't mean to clear that, but I guess now you'll see me type it in. Negative 2 parentheses negative 1 plus 4 parentheses negative 1. Oh, I forgot the second power. There we go. Plus 1. So that's exactly what we had written. So I'll go back to show you. That's what we wrote. Here you go. And the answer they give us is negative 5. So we are going to put that directly into the table as negative 5. Moving on to our next x value, which is 0. So x is going to be 0 now. So we have y equals negative 2, 0 squared plus 4 times 0 plus 1, which equals, going back to the EOC calculator, all I have to do is replace my last input, which was negative 1. I replace it with 0 now. So you can see what I've typed in is exactly what we wrote. The answer is 1. Try to do the rest on your own. I'm going to come back with the answer, but keep in mind the trick that I showed you before. That's going to happen. Okay, hopefully you plugged in 2 and 3 into your EOC calculator, or you noticed or remembered that there's going to be a pattern here, and you'll get 1 and negative 5. Now we are going to plot the axis of symmetry on the graph, because after you finish your table, you do have to graph the parabola. So I'm going to plot the axis of symmetry. Remember, the axis of symmetry was x equals negative 1. I'm sorry, x equals positive 1, which is here, because this is the line for 1. This would be 1, then 2, 3, 4, 5, so on and so forth. And this is -1, -2, -3. Let me zoom in so you can see what I'm writing. -4, -5, and then 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay. So I plotted my axis of symmetry. Now let's plot the vertex, which is in the middle of our table, 1, 3. 1, 3 is located right here. I don't recall if I pointed this out before, but thinking back to lesson 8.1, with A being -2, we should identify that that means it is going to open downward since the A is negative, because A is negative. Okay, so when we do plot this parabola, we need to keep in mind that it will be upside down. Okay? All right, so I plotted the vertex. The vertex is here. Next point we're doing is -1, -5. So -1, -5. Oh, I can't believe I did that. That's not good. These are negative numbers underneath the x-axis, right? Okay. So -1, -5 will be located here. Then 0, 1 is your next point. 0, 1 is located here. We already did the vertex. So next we have 2, 1, which is here. And then 3, -5, which is right here. Okay? So now you can see kind of the shape of that parabola that's going to be opening downwards. Okay? That automatically fixed it, but I didn't want that to happen, so let's try that again. There we go. Kind of looks like a V, but it should definitely be a U shape, not a V. So it doesn't come to a sharp point. It's more of a rounded point. Okay? And that is the end. Oh, no. We need to do domain. We know that domain will be all real numbers for quadratics, which means all x values are a part of a parabola, because the parabola just continues on forever and ever. Now that our parabola is facing downwards, the range is going to be y is less than or equal to your highest number in the table. The highest number in the table is 3. So y is going to be less than or equal to 3. All numbers that are less than or equal to 3. Let's start problem number 6. In problem number 6, the equation is y equals -x squared minus 2. So first we're going to begin by writing down some things that we know. We know that a is -1, b is 0. There's no bx term here, so b is 0. And c is -2. We also know that the parabola will open downward because a is negative. So I already mentioned earlier that I am not going to continue working out the axis of symmetry and the vertex, since you've already learned how to do that in lesson 8.1. Therefore, give me 1 second here. Okay, we're just going to go ahead and start by saying that we know that the axis of symmetry is going to be 0 since there's no bx term. And we've seen this happen many times before. You're going to have to plug that 0 in on your own, and you'll find that the vertex will be 0, -2. Now, as you know, the next step is to place 0, -2 in the middle of your table, just like it would be in the middle of the parabola. Now you're going to choose some numbers that come before 0 and some numbers after 0. We're going to do -1 and -2, and then also 1 and 2. Keep in mind here, we're going to see a pattern happen. So I really only need to plug in the first two x coordinates to get the y coordinates. Because once I get these two, I'm just going to repeat them. This y coordinate will be the same as this one. And then this one will be the same as this one, to make that mirrored parabola on both sides of the axis of symmetry, right? Okay. So let's go ahead and plug them in. We start by copying the equation, y equals -x² minus 2. And then for x, we are putting in our first x, which is -2. So now we have y equals -2 to the second power minus 2. Plugging that directly into the EOC calculator. -2 to the second power minus 2. You can see I've typed in exactly what I wrote. And that answer is -6. So now I write -6 next to -2 in the table. All right, now I'm going to do -1. So instead of x, we're putting -1, substitution. So y is equal to -1 to the second power minus 2. In the EOC calculator, I can just replace the -2 I input earlier with -1. Oh, -1. Here you can see I've typed in exactly what we just wrote, and the answer is -3. So that EOC calculator is very helpful. Again, as I said earlier, I'm just going to repeat those values because I know that when I plug in or when I substitute 1, I'm going to get -3. And when I substitute 2, I'm going to get -6. You can try it yourself to check and make sure, but that's exactly what's going to happen. So now I'm going to graph our parabola. Again, just to remind you, the steps to graphing the parabola is the first thing you're going to graph is your axis of symmetry, which is x equals 0. And as we said before, the axis of symmetry, the line for x equals 0 is the y-axis. Similarly, the line for y equals 0 would be the x-axis. Okay, so I've graphed my axis of symmetry. Now I am going to plot the vertex, which is at 0, -2. So that's here. If I zoom in, I can see that this line would be -1. This line is -2, -3, -4, -5, -6. And then 1, going up now, 2, 3, 4, 5, 6. Here, -1, -2, -3, -4, -5, -6. And on the other side, 1, 2, 3, 4, 5, 6. Okay, so I plotted the vertex. Now I'm going to the points that are in my table. First point is -2, -6, which is here. Pause the video and see if you can graph the parabola yourself first, and then press play to check your answer. Okay, so your parabola should look something like this. Remember, we did say it's facing downward. Here are the 5 points that are in our table, starting with the vertex in orange. Now let's try the domain and range. As said before, the domain for quadratic functions should be all real numbers. In other words, represented by this symbol here. And domain, I don't know if I said this earlier, but you should have learned about domain and range back in linear functions. But domain pertains to the x values of your function. So looking at our graph, our parabola here, here are the x values, these numbers here. And you could see that if the parabola continues on downwards, like continue forever and ever downwards, these x values are going to continue to go this way as well, right? So that's why we write all real numbers, because we're saying that literally all of the x's, all of the x numbers, or the x values, will be included in the parabola. Okay. And then range, we know we have to look at the graph for the range, and we can see our graph represents all numbers that are less, y's that are less than or equal, y's that are less than this y value here, right? All of the y values that are less than that number. So that's -2. Okay. And a trick for the range is, when it comes to quadratics, is if your parabola is facing upwards, it's going to be y values that are greater than or equal. So you would switch this sign the other way if your parabola is facing upwards, greater than or equal. And then this number should be the y coordinate of your vertex, right? Because we're talking about y values, so we are going to look at the y coordinate. And the vertex is always the highest point or the lowest point in the parabola. So if the parabola is facing upwards, the vertex would be the minimum, the lowest point. But if the parabola is facing downwards, then the vertex would be the highest point, the maximum. Okay? So you can always get your range from the vertex. All right. Let's go to number 8. Okay. Again, we're going to start by listing some things that we know. We know that the a value is -1. Oh, sorry, not face. Let's put open. Open down. The parabola will open downwards because a is negative. We know that b is +4 and c is +3. Okay. Again, take some time to pause this video and try to find the axis of symmetry on your own. Okay, So the axis symmetry is x equals 2, and the vertex is 2, 7, 2, 7. We know that we go to our table and place the vertex right in the middle of the table. Choose some numbers that are below 2, less than 2, and numbers that are greater than 2. Also, to make sure that you've chosen the correct values, look at your numbers and make sure they're in order. 0, 1, 2, 3, 4, right? Or even if I go back to number 6, -2, -1, 0, 1, 2. These are getting, sorry. These are growing. These numbers are growing. They're getting higher. Okay. So now we're going to recopy our equation. Y equals -x to the second power plus 4x plus 3. And for x, we are going to plug in our first x value, which is 0. And again, we're only going to substitute the first two x values because we know that the pattern will repeat for the last two over the axis of symmetry, over the vertex. Okay, so I'm plugging 0 first. So wherever I see x, I'm going to substitute 0. So now I have y equals -0 to the second power plus 4 times 0 plus 3. And I'm going straight to my EOC calculator. -0 second power plus 4 times 0 plus 3. And of course, we get 3. Now I'm going to substitute 1. For x, because that's my next x value. So we have y equals -1 to the second power plus 4 times 1 plus 3. Back to my EOC calculator, I'm just going to replace the zeros with 1s. Here I've typed in exactly what we wrote, and the answer is 6. And I know that these numbers are just going to mirror each other. Okay. Before I graph, I'm going to go straight to my domain and range this time just to switch it up. The domain should be all real numbers. And the range, since it's opening downward, should be y values that are less than or equal to the y coordinate in my vertex. Okay. Let's move to graphing. I'm going to start by graphing the axis of symmetry, which is x equals 2. So that's going to be this line here. And then I'm going to plot the vertex, which is 2, 7. So I'm going to put some numbers first. It's going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. And I just kept I'm just going to write the positive numbers because looking at my table, I can see that I don't have any negatives at all. So I don't need to write them. Okay? So vertex is 2, 7. That is here. First point is 0, 3. Here you go. Next point is 1, 6. Next point is 3, 6. And then 4, 3. And as you can see, we have our perfectly symmetrical parabola. Done. All right, I believe number 10 is our last example. Yes, number 10 is the last example. Zooming in. Our equation is y equals negative 3x squared minus 18x minus 20. So we're working with a bit of some larger numbers here. A is negative 3. B is negative 18. C is negative 20. That's what we know. We also know that this is going to open down since A is negative. Take some time to work out that axis of symmetry on your own. You should get that the axis of symmetry is x equals negative 3. And the vertex, when you substitute negative 3 here and here, you're going to get that the vertex is negative 3, 7. We go to our table and we put negative 3, 7 right in the middle. The domain should be all real numbers. And the range should be y's that are less than or equal to our y coordinate in the vertex. And it's less than or equal since it opens down. Okay, remember, opening up, you're going to put greater than or equal for the range. All right, I'm going to choose some numbers that are less than negative 3 and some numbers that are greater than negative 3. Next step, we plug those numbers into the equation. First, I need to copy the equation, negative 3x squared minus 18x minus 20. Wherever I see x, I'm going to substitute my first x value, which is negative 5. So negative 5 is going to go here and here for both x's. So now I have y equals negative 3 times negative 5 to the second power minus 18 times negative 5 minus 20. And I'm going to type that directly into the EOC calculator as usual. So that's negative 3 parentheses negative 5 to this. Oh, that's clear. To the second power minus 18 times negative 5 plus, minus 20 is the correct equation. This is what I've typed in, exactly what we wrote. Answer is negative 5. So I substituted negative 5 and I got back negative 5. So I'm also going to put that here since it is a mirror image. Now I'm going to substitute negative 4 as my next x value. Copying the equation, we have y equals negative 3 times negative 4 to the second power minus 18 times negative 4 minus 20. Going back to my EOC calculator, all I have to do is change the negative 5s to negative 4s. Zooming in, you can see I've typed in exactly what we wrote. The answer is 4. So we have 4 here and 4 here. Okay. When it comes to graphing, you want to do your axis of symmetry first or your vertex first. Either or is fine. Okay. Axis of symmetry is x equals -3, so I'm going to plot x equals -3 as the axis of symmetry, which is here. Zooming that in, I have my -1, -2, -3, -4, -5. And then 1, 2, 3, 4, 5, 6, 7, because I do see that I have a +7 in the table. Oh, but that's a y value, so I didn't even need to go that far. There you go. But in the y's, I need to go up to 7. 1, 2, 3, 4, 5, 6, 7. -1, -2, -3, -4, -5, -6, and -7, just to keep it even. Okay. So, axis symmetry done. Let's go ahead and plot the vertex at -3, 7, which is here. Now we have -5, -5 here. -4, 4 here. -2, 4 here. And then -1, -5 right here. So that looks like a very skinny parabola. Okay. Let's try our best to shape this. Let's do that instead. And there we have it. The parabola is graphed.